Our immune systems must be able to differentiate between hostile invaders and our own bodies. Failure to do so results in autoimmunity, which is leading to a catastrophic set of events that results in the destruction of our own cells and tissues by our own defense mechanisms. Certainly not ideal. So we've invited Dr. Paulo into studio to discuss some of the reasons why this happens. Now, Paulo, please let's start with just sort of a definition and a clarity of what autoimmunity actually is.
All right, so autoimmunity is the presence of antibodies which are produced by white blood cells, by cells of the immune system, against one's own tissue. And that results, of course, in the destruction of tissue. It can result in abnormal growth of an organ and in the dysfunction of an organ.
Okay.
The typical examples of autoimmune diseases are diabetes type 1, for example, celiac disease, multiple sclerosis, rheumatoid arthritis, lupus. These are all typical autoimmune conditions. So it's a loss of self-regulation.
Okay.
There's a degree of it as well when the immune system has an exaggerated reaction, such as in asthma. So it also leads to the loss of regulation, as well as when the immune system is subjected to having to fight chronic infections. So in HIV, the constant fight leads to the disruption of the functions of T helper cells, and that leads to the loss of regulation as well.
Right. So some of these conditions are certainly quite common. We hear about them quite commonly. But I mean, autoimmunity in general, is it quite a common thing? How prevalent is it in the world?
Well, that depends on which journals you read.
Okay.
So there are estimates between 1 and 3%, and there are estimates between 5 and 10%. Remember, these are all estimates. We don't quite know, because autoimmune diseases manifest themselves in different levels or grades, or in different intensities, if I may say so. So it's obviously the more severe intensities that get seen. And there could be people with a low level or low intensity autoimmune condition that for some reason remains there, that nobody knows about. So in as much, because if you think about it, even 5 to 10% sounds like a very low number.
Yes.
But if you have to think about the people you know, family and otherwise, and think of rheumatoid arthritis, you'll come up with a few. And everybody will come up with a few.
Yeah.
So it seems to be more prevalent than what the official figures say.
Okay.
So
and
it's kind of
is there an increase in autoimmune conditions due to sort of modern lifestyles and things?
Yes,
that
definitely.
Definitely.
Yes, there's an increase in prevalence because of what we are exposed to, and because of modern habits that we are now engaged in.
Okay. And in terms of the causes of autoimmunity, I mean, where does it begin? What are the triggers, and how does it progress?
All right, nobody knows the real causes. There are obviously a number of hypotheses and possible triggers. So we've got the genetic component, which basically would say that your immune system wasn't programmed properly. So it's got a flaw here or there, so it increases the risk of it turning against your own tissue. Then there's the theory that speaks about the immune system may become confused because of having to constantly defend itself against a specific enemy, a virus or a bacteria, whose protein coding is somewhat similar to the protein coding of one of the person's own tissues.
So it's mild confusion which causes destruction.
So think of A, B, C, D, E, and yours is B, C, D, E, A. And your immune system could become a little bit confused. Then there are nutrient deficiencies, such as vitamin D3, we know for a fact, that can increase the risk of your immune system going haywire. Obesity plays a major role. Obesity, for example, reduces the number of regulatory T cells, which are very important white blood cells that prevent autoimmunity. And in obesity, those cells, or the level of those cells, drops. So that also plays a role. And then, of course, physical and psychological or emotional stress can also tip the immune system, tip that kind of immune system that is already on the edge, so to speak, that is already finding it difficult to differentiate between foe and friend.
Okay,
Yeah.
okay. So Paulo, in terms of our immune system regulating in general to prevent this autoimmunity, what is the cycle of the system that it keeps things within a balance normally?
Well, it's highly complex, obviously, but let's speak about the regulatory T cells that I've just mentioned. So regulatory T cells are white blood cells, and one of their functions, or two of their functions, is to maintain balance in the immune system and to prevent autoimmunity. Okay. Then you've got effector T cells, and their job is to promote inflammation as the standard immune response.
Right.
So inflammation is a standard immune response when the body is attacked. It has to promote inflammation in order to deal with the attackers. Now, the regulatory T cells have charge over the effector cells, if I may say so, only allowing them to only promote a certain amount of inflammation.
Yes,
so that they
what's
don't
needed
go
for the process.
correct, they don't go overboard. So that's one of the ways in which this is accomplished.
Okay. Now, Paulo, we understand that glutathione has a role to play in maintaining those T cells or keeping them at optimal levels. How does that play into each other?
All right. So glutathione is essential for these regulatory T cells to function properly. If their glutathione levels drop, their suppressive capacity on the effector cells that promote inflammation is reduced. So the effector cells are not controlled, basically. So when glutathione levels drop, the body must manufacture more glutathione because the body is able to. Now, glutathione is made up of 3 amino acids: glycine, cysteine, and glutamic acid. However, there is a 4th amino acid, serine, which the body can use to transform into glycine or cysteine. So what the body does is it increases the increases the absorption from diet of serine and the formation of serine within the body.
Okay.
Okay. Now, when that happens, unfortunately, it further suppresses the regulatory T cell function. Okay. And then also the effector cells, in the presence of increased serine, actually produce more pro-inflammatory processes, and cancer cells use serine to proliferate.
Okay.
So the picture is that the regulatory T cell keeps serine, the amount of serine available, under a certain threshold. For that, it needs glutathione. When glutathione drops, the very same serine is needed to make glutathione. So the body will just bring in as much as it can, and in doing that, if there are cancer cells present, they will steal some of the serine, so to speak, to proliferate. And the effector cells will continue to increase inflammation.
So the point here is that we need to maintain levels of glutathione.
Yes, in
and
the
build
regulatory
the
T
correct
cells.
building blocks of glutathione so that it's got a supply.
Correct.
So now this obviously is going to bring in the question of supplementation to maintain
Invariably,
or to support.
invariably in most cases.
Right, yeah. So now let's talk about the supplementation of glutathione, because if we are, as you say, the body uses 3 different amino acids to generate glutathione. If you're supplementing glutathione, are you supplementing the complete product?
Yes. Okay. So when if you produce glutathione and you place it in a capsule, unprotected in terms of its delivery, when it arrives in the digestive system will invariably break it down into its 3 constituent amino acids: glycine, cysteine, and glutamic acid. And it absorbs them as amino acids, not as glutathione. Once in the body, once absorbed, it can reconstitute glutathione. But you can't tell the body to do that. You can't say use this and just produce glutathione again. If the body needs cysteine somewhere else for something else, it will take it. So the point made here is that if you take a certain amount of glutathione, you are never going to get the same amount of glutathione once the amino acids are absorbed. Okay. So clinical trials have been conducted, and people have been given glutathione without any special delivery system, and there has been no increase in their glutathione levels, either in the blood or cellular levels.
So the body's using those amino acids for other purposes.
For something else.
There's an urgent
need. because those are building blocks. Those are bricks that the body uses to build tissue and to build enzymes, which we are burning at an incredible rate every single second. So that's the challenge in taking glutathione. It has to be as a supplement, it has to be taken with a special delivery method that will preserve the glutathione as glutathione once it is absorbed.
Okay. So Paulo, we have chosen Biomax glutathione liposomal to put into our Real Health Medicine cabinet today. This liposomal element, I understand, is the part that's going to help to solve the problem that you just mentioned about this breaking down. Tell us how that works.
Okay, so that means that the glutathione in this case, which is a patented form from Japan, it's called Satria, and it has had its own clinical trials, human clinical trials, which I'll speak about now. But the liposomal delivery means that the glutathione, the Satria, is placed inside a phospholipid molecule.
Okay.
It's a fatty-like molecule. Imagine a Star Wars payload in a cargo little ship, so that the immune system absorbs the entire ship, as it were. So it doesn't touch the contents.
Right.
Once absorbed in the bloodstream, the ship delivers its contents. Now, once in the bloodstream, if it is glutathione, it remains glutathione.
There's no further processing or breaking down.
No, because there's no digestion.
Right, okay.
So that is the liposomal delivery.
Okay.
Now, Satria has been used in clinical trials, and it has shown that it increases blood levels by 17 to 39%, and it increases cellular levels by 260%.
Good heavens.
Okay. Furthermore, they've tested, because one of the concerns was if you supplement with glutathione for an extended period, does your body stop making it?
Right.
In my personal point of view, that was a silly concern, because when you consume glutathione or any other substance for that matter, it doesn't go sit in a storeroom.
Mm-hmm.
Your body is utilizing it. So it was found that even after 6 months of supplementation, the production by the body was still maintained.
Okay.
So your body still produces it. And I think this speaks to the fact that what we said just now, our diets are nutritionally deficient. Even with supplementation, invariably, we're just not getting enough. Mm-hmm. And one might say, but what happened 100 years ago? My great-grandfather, they didn't have supplements. The nutritional content of their food was infinitely greater. Mm-hmm. It was nutritionally dense. So they were eating different food for all effects and purposes, even though it looked the same on the plate. They were not exposed to the challenges that we are exposed in terms of electromagnetic waves and everything else. They were not exposed to the type of stresses that we are exposed as well. So they lived on a different planet. Literally.
It does seem like that.
So that is what we need to understand when we speak about why supplementation is going to become almost essential.
Yeah, absolutely. Paulo, glutathione is also kind of known as a super antioxidant.
Yes,
tell us about some of the other benefits of glutathione.
Yeah, well, it is the most powerful antioxidant.
Mm-hmm.
And thankfully, that is why the body makes it.
Yes.
But because it is a powerful antioxidant, it is used in great quantities continuously, because remember, there are free radicals in the body all the time. Okay, and so as an antioxidant, of course, it will protect against the accelerated aging process, for example.
Right.
Okay, it will protect against cancer cells developing. So the list of benefits is very large.
Right. And anybody should be concerned or cautious when taking glutathione as a supplement?
It has no interactions with drugs, although it is generally recommended that if one is on blood thinners, such as warfarin, one should not take glutathione or should consult with a knowledgeable healthcare practitioner.
Right. And where can we find this glutathione supplement?
It's available in health shops and pharmacies, I believe.
Wonderful. Dr. Paulo, thank you. Some lovely insights there about glutathione. Thank you for joining us.